Hey everyone, and welcome to this explainer created by Forge College. Today, we are taking all those theoretical concepts surrounding Solana cross-program invocations, CPIs, and we're finally turning them into runnable, concrete client-side code. So if you've been wondering how to actually make these programs talk to each other in the real world, you are in the exact right place. We're going to be looking at implementing client interaction for program calls. Let's just dive right into it.
Just like any solid engineering project, we've got a really clear blueprint for today's session. We'll quickly run through our blueprint to runnable reality, setting up your environment, mapping the account roles, building the instruction, running through our submission checklist, and finally verifying and debugging. All right, Section 1, Blueprint to Runnable Reality. So, just to anchor ourselves in the Programming with Solana track, and specifically our module on applying program templates, let's look at exactly what we're building today. In our previous lesson, designing CPI instruction flows, we were basically sitting in the architect's office, right? We drafted the designs, we mapped out our account meta lists, and we made sure our authority checks ran in the right order. But today is the construction phase. We are literally mixing the concrete and laying the actual bricks using TypeScript. We're taking that high-level design and making it fully executable.
Okay, moving right along to Section 2, setting up your environment.
Well, before our code can start building anything, we obviously need to prep our construction site. You're going to need a minimal node project equipped with the Solana Web 3 library, so a quick npm install at solana/web3.js will get you the tools you need. But listen, here is the absolutely crucial step. Whatever you do, do not skip firing up your local test validator. This is literally where the magic happens locally.
You can think of this local validator as your own private rehearsal stage. It's a localized, super-fast instance of the Solana blockchain running entirely on your machine. It's there to ensure your transactions perform flawlessly, hit all their marks, and deliver their lines perfectly, way before they ever have to face the real network audience.
Which brings us to Section 3, Mapping the Account Roles. Now that our stage is set, we get to meet our strict bilingual bouncer. This is the code that dictates exactly who gets into our transaction and what they're actually allowed to do once they get inside. This table right here, this is your transaction's VIP guest list. Notice the columns. We've got the role, the public key, whether they are a signer, and whether they are writable. For instance, the payer has to be a signer and writable because, well, they're footing the bill. The authority needs to sign to authorize the CPI, but doesn't actually need to be writable. And listen, if a signer forgets their ID or a read-only account like config tries to write data without permission, our bouncer will flat out reject them. No exceptions whatsoever.
In our client code, every single row on that guest list gets translated into what we call an AccountMeta object. This is the fundamental building block that strictly enforces those privileges at runtime. It basically tells the Solana runtime exactly how each account is allowed to participate. And I'll tell you right now, incorrect account metas are the single most common cause of CPI failures. So, keeping your design table handy while writing this code is an absolute must.
You also need to be extra careful when dealing with your PDA or program-derived-address. This is usually the account getting modified by the invoked program. The crucial thing to remember here is that you must derive its address in your client code using the exact same seeds that the invoked program is expecting. Because if your client uses the seed demo, but the program expects user data, you're going to be talking to a completely empty, totally incorrect address, and your transaction is just going to fail.
All right, on to Section 4, Building the Transaction Instruction. With the guest list sorted and our PDAs properly derived, it's time for our client code to step up and act as the ultimate translator. I really love this framing from the documentation. It perfectly captures the mental model you want to have. Think of the client role as translator plus checklist. Your client is basically translating your architectural design into a transaction instruction object while simultaneously enforcing a super strict checklist of cryptographic rules.
Let's actually look at how this builds into a workflow. It's essentially a four-step assembly line to construct the transaction. First up, you load your connection to the local validator and grab your key pairs from your local JSON files. Second, you build and serialize your instruction data, keeping it nice and compact, maybe just a single command byte and an argument. Third, you programmatically resolve that account meta array we were just talking about. And lastly, you package all those elements into a transaction instruction, toss it into a transaction, sign it, and send it off for delivery.
Okay, Section 5, Submission and the Checklist.
So once your transaction is fully assembled on the belt and signed by all the required key pairs, it's time to submit it and, well, wait for the delivery tracker. To do this, we use a really fantastic utility called Send and Confirm Transaction. I'm not going to lie, calling this function is highly satisfying. It is literally exactly like ordering a pizza and watching the app's delivery tracker. You dispatch the order to the network, and the utility just waits, watching the blocks until you finally get that glorious confirmed notification printed right there in your console.
Finally, Section 6, verifying and debugging outcomes. Because as we all know, software development isn't always perfect, right? What actually happens if the pizza goes to the wrong address, or the transaction just fails entirely and crashes? Well, when things go wrong, or honestly, even when they go right, you have to check the receipts. You don't just blindly trust that the client didn't throw an error, you use the validator CLI. By running Solana transaction with your signature, you can inspect the program's emitted logs to make absolutely sure the CPI actually executed. And by running Solana account, you can confirm that the data inside the PDA actually changed exactly how you expected it to.
Now, if things do crash, just consult this quick debugging checklist. If you get a missing required signature error, that is pretty much the cryptographic equivalent of getting all the way to the drive-thru window and realizing you forgot your wallet. You need to go back, check your key pairs, and make sure that isSigner flag is set to true. If you see account not writable, double-check your flags and make sure the account actually has enough lamports. And if it just vaguely says program failed to complete, you've got to dive deep into those validator logs we just talked about to find out exactly where the program panicked.
By following these exact steps, you are going to have a beautiful, runnable TypeScript client that perfectly invokes a Solana program on your local setup. But it does leave us with a pretty thrilling question for our next explainer. Your transaction works perfectly here in isolation, but what actually happens to it under heavy load? How do we capture structured logs, reduce confirmation latency, and really optimize this stuff when the network is under massive pressure? Well, that is exactly what we're going to tackle next time.
And that wraps it up. Thank you so much for joining us for this explainer produced by Forge College. It has been incredibly fun breaking down these CPI client interactions with you all today. Make sure to head over to forge.college to dive much deeper into this subject, grab some hands-on practice, and explore a ton of other fascinating Web3 topics. Until next time, happy building!